I'm going to read parts of this book, Magnets Push, Magnets Pull by David Adler. Magnets Push, Magnets Pull. I'm going to read part of this book. A world without magnets would be a world without computers, printers, cell phones, televisions, vacuum cleaners, microwave ovens. That's a magnet's invisible pulling and pushing force called magnetism that helps power all these devices. Magnets are attracted to anything made of iron, steel, nickel, or cobalt, or some less plentiful metals. There are two kinds of magnets, simple magnets and electromagnets. You are probably most familiar with simple magnets, the kind you find in toys or use to hold papers to your refrigerator door. Do you have a simple magnet? If you do, you can use it as a metal tester, but be careful with your magnet. Do not bring it close to a watch, clock, computer, television, or any delicate instrument. It could damage them. Test some U.S. coins. Does your magnet stick to any of them? It shouldn't. U.S. coins aren't made mostly of iron, steel, nickel, or cobalt. Pennies and nickels, dimes and quarters are mostly copper. Does your magnet stick on the hood of a car? Does it stick? It should. Most cars are made from steel. Take a few cans from your pantry. Does the magnet stick to them? It may stick to some, but not others. Some cans are made of steel and others are made of aluminum. Simple magnets come in many shapes and sizes. If you have a magnet of any size, you can use it to test the force of magnetism. Place a few small paper clips, or you can use the magnets I sent home, on any table or flat surface. Put the magnet on a same surface about 1 foot away. Slowly move the magnet toward the other items. You're just moving the magnet, but the paper clips will soon be moving too. They'll slide across the table and stick to the magnet. Your magnet's invisible pulling force pulled the paper clips across the table. If your magnet is strong enough, it'll work through paper, water, and glass. Place a paper clip on a sheet of paper. Hold the magnet beneath the paper. Without ever touching the paper clip, you should be able to use the magnet to move it. Drop a few paper clips in a shallow bowl of water. Hold your magnet at the surface of the water. If the magnet is strong enough, it will pull the clips through the water. With a really strong magnet, you would be able to hold it against the side of the bowl and move the clips on the other side of the glass. The two ends of the magnet are called its poles. Each magnet has two poles, a north pole and a south pole. You can test your bar magnet to see which is its north pole and which is its south pole. Place both magnets on a table or any flat surface. Place them at least 1 foot apart. Line them up with one pole of each magnet facing each other. Slowly move each magnet toward each other. That's all I'm going to read here, so you have enough information and ideas to start playing around with the magnets I sent home with you. See what you can figure out.